So this video is an introduction to thermodynamics, its elements, and thermochemistry. Okay? So punta muna tayo sa bigger picture. So physical chemistry is a branch of chemistry that employs the application of physics to describe chemical phenomena. So direct application to ng mga laws and equations of physics para makapag-describe tayo ng mga chemical systems and its processes. Okay? So there are branches of physical chemistry. So the first branch is quantum chemistry. So sa quantum chemistry, application siya ng quantum mechanics to chemical systems. So specific tayo sa quantum mechanics, okay? So structure and reactivity of electrons and electronic orbitals, okay? So ano-ano yung mga results kapag iniba-iba natin yung mga parameters, okay, associated with the electron's energy and movement around an atom. Okay? So ano-ano rin yung mga nagiging properties ng mga molecules once the atom combines with another atom, okay? Kapag nagkakaroon na ng overlap of orbitals, ano nangyayari doon sa ating resulting molecule. So that is actually a part of the discussion in quantum chemistry. Okay? So next is thermodynamics. Thermodynamics in general deals with forms, transfer, and conversion of energy. So ano-ano yung mga types ng energy? Tapos paano siya natatransport o natatransfer from one system to another or from one particle to another? Paano rin siya na-i-interconvert from one type of energy to another? Okay? So under that, we have chemical thermodynamics. So thermodynamics siya focused on chemical systems. So every time meron tayong physical changes or chemical reactions, okay, we are studying their properties through chemical thermodynamics. So this is the fundamental study of the energies of chemical species. Okay? Pwede nating ma-predict din yung spontaneity ng processes na yon or yung future fate, kumbaga, ng ating mga processes. Okay? So the next one is thermochemistry. So thermochemistry focuses on the heat or energy involved in physical or chemical changes. So every time meron tayong process, ano yung mga heats absorbed or released, okay? Ano yung mga changes associated with either heat absorption or heat release ng ating mga processes, okay? So ano nangyayari dun sa system kapag may dinidescribe tayong energy, kung ano man yung nangyayari sa energy na yon, paano siya nakaka-apekto dun sa ating system. Okay? So finally, we have chemical kinetics. So chemical kinetics is focused on the speed or the rate of the mechanism of chemical processes. So paano nangyayari yung reactions, okay? And ano yung mga parameters that could affect the rate of these chemical reactions or chemical processes in general. Okay? So now let's focus on thermodynamics. Again, thermodynamics is a branch of physics that deals with the forms, transfer, and interconversion of energy across various processes. Okay? So ano-ano yung mga elements naman ng thermodynamics? So kailangan nating ma-distinguish yung mga elements ng thermodynamics bago tayo mag-discuss ng mga concepts nito. Okay? So here are the elements. So we have the universe. So the universe is everything. So lahat ng bagay, okay, nandun siya sa loob ng universe. So yung universe natin may tatlong parts. Okay? Yung universe ay may system. So sa system, it contains the object or process being observed. Ito yung ating focus of study. Ito yung ating interest, yung system. Kung ano man yung nangyayari dyan, yun yung ating ino-observe. Okay? So yung surroundings, that's anything not in the system. So that's the rest of your universe. Okay? So yung universe nyo ay may system and surroundings. Yung surroundings, kahit anong bagay na wala doon sa ating system or doon sa ating process or object na ino-observe doon sa system. Okay? So yung line or imaginary line or actual line between the system and the surroundings is called the boundary. So kung ano man yung nagko-cross from the system and the surroundings, dumadaan siya doon sa ating boundary. Okay? So focus muna tayo dun sa systems. So ano-ano yung mga types ng systems sa thermodynamics. Okay? So we have, first, an open system. So kapag sinabing open yung system mo, nakakapag-cross yung heat tsaka yung matter across the boundary. So nakakapasok sa system and nakakalabas din sa system yung heat and matter. Kung ano man yung laman ng system na yon, either energy or matter, nakakross siya dun sa boundary. So that's an open system. Okay? So yung closed system naman, nakakapag-cross dun sa boundary yung heat, pero hindi yung matter. So kung nasa labas yung matter, mananatili siya sa labas. Yung mga nasa loob naman ng system, mananatili siya sa loob. So hindi pwede mag-cross ng boundary yung ating matter. Okay? So that's a closed system. Sa isolated system, okay, hindi makapag-cross both yung heat and matter. So kung ano man yung heat and matter sa loob ng system, hindi siya makakalabas. Yung mga heat and matter sa labas naman ng system, hindi siya makakapasok. Okay? So yung boundary, hindi niya pinapermit yung passage both ng heat and matter. Okay? So now let's discuss the concept of equilibrium. So equilibrium is a state where there are no apparent changes in the properties of the system. Okay? So we can only use thermodynamics to describe equilibrium states. So for example, you have an initial state, tapos nagpalit siya into the final state. Okay? So ang ma-describe lang ng thermodynamics sa iyo ay yung kung ano yung parameters ng state 1 or yung initial state, tsaka yung state 2 or yung final state. Hindi niya ma-describe sa iyo kung paano nagpalit yung state 1 to state 2. Ang ma-describe lang niya is, for example, gaano karaming energy yung nawala or nadagdag doon sa system. Okay? Gaano karaming pressure or volume yung nawala or nadagdag doon sa system. So yung mga net changes lang yung nade-describe niya. Yung process of change actually ay discussed by chemical kinetics. Doon naman nakafocus yung chemical kinetics sa kung paano nag-change yung state 1 to state 2. Okay? But as far as thermodynamics is concerned, ang describe lang niya is yung state 1, which is an equilibrium state, yung initial, and yung final, which is the state 2. Okay? Yung mga parameters ng state 2. Yun lang yung describe niya. Okay? So, we have three types of equilibrium. So for the first one, we have mechanical equilibrium. So sa mechanical equilibrium, the forces across the boundary are balanced and the net force or pressure is zero. So yung work done to the system, okay, is equal to the work done by the system. So kapag work is being done to the system, ibig sabihin papasok yung work or pa-compress yung ating action, that's positive work. Okay? Negative naman yung sign ng work kapag nag-expand yung system natin or palabas yung action ng ating work. So kapag mechanical equilibrium, yung negative work mo is equal to the positive work. So no net change in the size of our system. Hindi siya nag-expand or hindi siya nag-contract. Okay? So that's mechanical equilibrium. So for the next one, we have thermal equilibrium. So sa thermal equilibrium, heat transfer across the boundary is balanced. So kung ano man yung heat supplied, kapag heat supplied, positive Q, equal lang siya sa heat released or the negative Q. So, negative Q is equal to the positive Q kapag sa thermal equilibrium. So, kung ano man yung magnitude ng input na heat, yun din yung magiging magnitude ng output na heat. Walang net change dun sa heat, okay, ng ating system. So, heat transfer across the boundary is balanced. So, the temperature inside and outside the system are also equal. Okay, kasi wala tayong net change in Q. Wala tayong net heat output or input. So finally, we have material equilibrium or chemical equilibrium. So kapag naman sa chemical equilibrium, the net change in the mass or the number of components or the number of types of components are equal or hindi sila nagpapalit. So kung naman yung input ng mass, equal din siya sa output ng mass. So pareho lang yung magnitude, opposite yung direction. So material transfer across the boundary is balanced. Okay? So walang net change in the amount and number of components. So hindi nagbabago yung amount ng components, pati yung types of components present. Okay? So now let's discuss the zeroth law of thermodynamics. Okay? So the zeroth law states that thermal equilibrium is transitive. So ano ibig sabihin ng transitive? For example, we have three separate systems, A, B, and C. Tapos yung A ay in contact with B, tapos yung B ay in contact with C. Okay? So if A is in thermal equilibrium with B, and B is in thermal equilibrium with C, then the zeroth law implies that A and C are also in thermal equilibrium with each other. So we can also conclude that A, B, and C have the same temperature. So that is the zeroth law of thermodynamics. Dinidescribe niya kung ano yung ibig sabihin ng equilibrium state. Okay? Tapos specific siya sa definition ng thermal equilibrium and yung transitive property niya. Okay? So the zeroth law also describes what a thermodynamic state is. So there are two ways to describe a state of a system at equilibrium. So for the number one, okay, we can describe the physical state. Pwede natin sabihin kung solid, liquid, or gas siya. Okay? So pwede siyang description ng isang thermodynamic system na nasa equilibrium. Kasi the phase or the state describes the kind of equilibrium that this system has. Okay? Pwede rin natin i-describe yung number of components and phases, pressure, temperature, and volume. Yung mga parameters na nagde-describe ng ating equilibrium state. Kasi hindi naman sila nagbabago as you change time. Okay? So through time, pareho lang yung nagiging parameters ng system na to according to the zeroth law, as long as wala kang net input or output ng heat or work or hindi mo tinatry baguhin yung system. Okay? So as long as nasa equilibrium yung ating system, you can describe the system in terms of these two parameters or these two types of parameters. Okay? So now let's discuss the first law of thermodynamics. So this states that the internal energy change of a closed system, so kapag closed system, again, hindi nagkakaroon ng transport of matter in and out the system. Okay? So this is equal to the sum of the heat absorbed or released, okay, that's Q, and the work done by or to the system, that's W. So delta U is the internal energy change or yung energy content ng ating system at constant volume. So sinasabi nung ating first law na to be able to change the state of the system, you either have to add or remove heat or you need to add or remove work. Okay? So yan yung mga bagay na pwede mong gawin para mapalitan ang state ng system. Kasi for example, yung pressure, you just have to change it from 1 atm to 2 atm for example. Hindi ka po pwedeng maglagay ng pressure kumbaga. So ang pressure hindi siya something na pinopossess mo or yung pwede mong ilagay. Okay? Yung pressure, napapalitan mo siya either by heating or cooling the system or pwede mo siyang i-compress or i-expand yung system mo. Okay? Hindi ka nakakapag-add ng 1 atm basta-basta kasi ang pressure ay hindi something na pwede mong hawakan at ibigay or kunin sa system. Okay? So to be able to change those state parameters, kailangan mo ng input or output ng either heat or work, or pwedeng both, okay? Input or output ng heat and work. Okay, so that's the first law. So sinasabi din ng first law that the energy of the universe is constant. So kung ano man yung net input or output ng energy mo, okay, kung ano man yung net energy content ng buong universe, constant yun. Okay? So, the energy of the system plus the energy of the surroundings should be equal to zero. So, lahat ng change na nangyayari, dapat conserve yung energy natin. Kasi, again, energy is neither created nor destroyed inside the universe according to the first law of thermodynamics. Okay? So, to be able to change state 1 to state 2, okay, meron tayong mga parameters na state 1, meron din tayong mga parameters na state 2. So, pwede kang mag-add or remove ng heat, pwede kang mag-add or remove ng work, and kapag open system, pwede kang mag-add or remove ng material. Okay? So, that's what the first law of thermodynamics is all about. Paano mo napapalitan yung state 1 and state 2, and you need to do this while following the law of conservation of energy. Kasi, again, the net energy of the universe is constant. Okay? So, we have two types of parameters or variables. We have the state variables and the path variables. So, yung state variables, these are parameters that do not depend on the manner of change. Wala silang concern sa kung paano nag-change yung state. Ang concern lang nila is yung initial tsaka yung final state. So, kinukuha mo lang is yung net change. So, final minus initial. So, yun yung ating state variables. Kapag naman path variables, these are parameters that change in value when the path is varied. So, depende dun sa path na tinitake mo, magkakaroon ka ng specific values ng ating path functions. So, ang example ng path functions natin ay Q and W, yung heat and work. So, sa state functions naman, yun yung pressure, temperature, volume, number of moles, yung delta U and delta H. Okay? So, yung mga state variables, hindi sila nagbabago kahit baguhin mo yung path. Basta initial and final states are the same. Okay? So, yun yung difference ng state tsaka path variables. Okay? So, let's discuss state functions and path functions in further detail. Okay? So, state functions, again, are parameters that depend only on the initial and final conditions and independent sila sa path of the process. So, for example, we have pressure. So, if we want to change a pressure from 1 atm to 2 atm, the delta P is just the final minus the initial pressure. So, that's 1 atm for delta P. So, pwede nating gawin yung iba't ibang paths para karoon tayo ng change in the pressure. Okay, so for example, mag-add ako ng 0.5 atm. So, magiging 1.5 atm siya. Pwede rin ako mag-add pa ng isa pang 0.5 para maging 2 atm na siya. So, that's a two-step process. So, ganun pa rin yung final state. So, pwede ako mag-add ng 1 atm straight. Okay, from 1 atm, mag-add pa ako ng 1 atm. So, magiging 2 atm siya. So, pwede rin nating dagdagan ng 9 atm. So, magiging 10 atm siya. Okay, tapos mag-subtract tayo ng 8 atm. So, magkakaroon tayo ng 2 atm. So, ganun pa rin yung final state. Okay, so regardless of the path taken, pareho lang yung initial and final state. So, therefore, same lang yung value ng ating delta P. Okay? So, we can also apply the concept of state functions sa mga phase changes. So, for example, we want to convert solid water at negative 10 degrees Celsius to gaseous water at 125 degrees Celsius. So, pwede tayong mag-add ng temperature plus 135 degrees Celsius, tapos mag-add tayo ng sublimation enthalpy. So, this sublimation enthalpy is the enthalpy needed to convert a solid to a gas. Okay? So, pwede itong path na to. So, pareho pa rin yung kanyang final state. So, gas pa rin siya at 125 degrees kapag in-apply mo itong dalawang ito. So, pwede kang ring magkaroon ng path na puro reversible yung process. So, ibig sabihin, isang parameter lang yung change mo per step. So, for example, mag-add muna ako ng 10 degrees Celsius. So, magiging solid siya at 0 degrees Celsius muna yung ating water. Tapos, i-melt natin yung water using the fusion enthalpy or the enthalpy of fusion. That's the energy required to convert a solid to a liquid at constant temperature. So, magkakaroon tayo ng liquid water at 0 degrees Celsius. So, mag-add tayo ng 100 degrees Celsius para ma-reach na yung temperature na to. So, liquid water na siya at 100 degrees Celsius. Okay? So, after nyan, papalitan natin yung phase. Gagawin natin siyang gas. So, we have to input the enthalpy of vaporization. So, vaporization enthalpy is the enthalpy or the energy needed to convert your liquid to a gas at constant temperature. So, magkakaroon na tayo ng water vapor or yung gaseous water natin at 100 degrees Celsius. Tapos, finally, mag-add lang tayo ng 25 degrees Celsius na temperature, ma-reach natin yung final state. Okay? So, regardless of the path, pareho lang yung initial and final state ng ating system. So, ibig sabihin, okay, this is an example or an illustration or an example of a physical phenomenon that is a state function. Okay? So, hindi siya nakadepende dun sa path. Pareho lang yung initial and final states niya. Okay? So, now discuss naman natin yung path functions. Again, path functions are parameters that depend on the path taken by the process regardless of the initial and the final states. So, as an example, we have yung work. Okay? So, work is a path function. So, paano natin may illustrate na path function siya? So, we let a certain ideal gas expand and then compress inside the container. So, kapag from state 1, which has P1, V1, and T1 as the state functions, okay, in-expand natin siya, at constant temperature. So magkakaroon tayo ng state 2 na P2, V2, and T1 kasi constant temperature siya. Tapos i-compress lang ulit natin para bumalik sa state 1. So magkakaroon ulit tayo ng P1, V1, and T1. So yung ating delta P ay equal sa 0, yung ating delta V equal siya sa 0, tapos yung delta T natin, since hindi naman natin pinalitan, that's also 0. So 0 lahat ng ating state functions. So how about the work? So pwede nating i-illustrate yung work done using the PV diagram or yung graph ng pressure versus volume. Okay? So ang gagawin muna ay ibababa yung pressure. Okay? So sa taas ng piston, ibababa muna yung pressure nun. Tapos you will let the gas expand. Okay? So mangyayari, mag-increase yung volume niya. So this point is actually P2 and then V1. Okay? Yung point na yun. Tapos dahil P2 na yung pressure niya, mas mababa na, mag-expand na yung gas mo. So magkakaroon ka na ng state P2 then V2. Okay? So this area here is the expansion work. Okay? So pwede nating i-illustrate or i-translate into equation yung work. Actually, work is equal to negative P dV. Okay? So integral siya nung ating P dV. So ibig sabihin area siya under this graph. So this is your work. Specifically, this is expansion work. Okay? So kapag ka naman i-compress mo yung gas from P2 V2, okay? So from P2 V2, itataas mo muna yung pressure above the piston. So magiging P1 ulit, tapos V2, tapos magko-compress yung gas from V2 to V1. Okay? So that's compression work. So kapag compression work, mas malaki yung kanyang magiging area. Okay, mapapansin nyo. Kasi inuna natin yung pressure increase bago yung volume decrease. So yung area ng graph na yan, that's the compression work. It's still, again, okay, work is equal to negative P dV, integral. Okay? So kapag ka sinubtract natin yung compression work, okay, tapos expansion work, that would be greater than 0. Okay? So magkakaroon tayo ng net application of work dun sa ating system. So hindi 0 yung magiging work done ng ating system. Okay? So that is your illustration of the path function. Okay? So ang mangyayari dyan, okay, meron tayong net work done pero wala tayong net change in the state. So ibig sabihin, work is a path function kasi may nangyari. Ibig sabihin, change natin yung system momentarily. Binalik lang natin siya sa initial state. So na-account yun ng mga path function. Okay? So now let's discuss the nature of heat and work. So ano ba yung heat and work sa thermodynamics? Okay? So let's discuss heat muna. So heat is a dissipative form of energy. So dissipative means it is a random spreading of energy from a region of higher temperature, okay, to a region of lower temperature. So kapag ka sa kinetic molecular theory, yung mga particles na may mas matataas na kinetic energy, ibig sabihin mas mataas yung temperature nila, natatransfer nila yung kinetic energy sa mga particles na mas mababa yung kinetic energy. So bibilis din yung mga particles na yun. Ibig sabihin nagkakaroon ka ng transfer of energy from the particles na mas matataas or mas mabibilis, okay, ang kinetic energy doon sa mga particles na mas mababa yung kinetic energy or mas mababa yung temperature. Okay? So mangyayari, nagkakaroon ka ng heat dissipation. Okay? So transfer yung heat through collision of those particles. Okay? So dissipation of heat can occur through the following processes. So first, convection. So sa convection, heat is transferred through fluid particles which are then dispersed. So for example, we have here a heated metal rod. So, nag-input tayo ng heat dun sa metal rod. Yung mga particles na malapit dun sa heated metal rod, okay, mag-heat sila, mag-increase yung kanilang temperature. So, kapag nag-increase yung temperature nila, bibilis sila. So, tataas yung kinetic energy nila. Magko-collide sila dun sa mga particles na mas malamig or yung mas malayo dun sa metal rod. So, nagkakaroon tayo ng net travel of heat from below tapos upward. Okay? So, with respect to this diagram. So, ang mangyayari, magta-travel yung heat upward, yung mga particles, may heat na rin sila sa itaas. Tapos yung mga mas malalamig na particles, mapupunta sila sa baba. Okay? So, pupunta sila dun sa metal rod. So, may heat din sila. Tapos, that's a continuous process. Kasi magkakaroon din ng mas mataas na temperature to, tapos magko-collide ulit sila dun sa mga particles na nasa itaas, and so on. So, continuous yung transport ng heat from this metal rod to these particles of the fluid. Okay? So, now we have conduction naman. So sa conduction, heat is transferred through direct contact due to molecular collision. So kapag ka yung system A ay connected sa system B through this particular material, okay? So ibig sabihin directly connected sila. Kapag hinit mo si A, mag-heat din si B through conduction. Okay? So direct molecular collisions to between the particles of A, tapos itong rod na to, tapos yung rod na yan, since may heat yan, magta-travel na yung heat sa B. Okay? So that's conduction. So nagta-travel yung heat from A to B kapag ka nag-input ka ng energy sa A. So next, we have radiation. So radiation is a heat transfer na walang medium. So heat is transferred without a medium. So kapag hinit mo si A, for example, at walang metal rod or anything na nakabit okay, sa A at B, so ibig sabihin yung A at B ay hindi in contact with each other, yung heat mo, magdi-dissipate siya through radiation. So magre-radiate lang yung heat from A, tapos maapektuhan si B. Magkakaroon na rin ng increase in temperature. So this type of heat transfer does not require a medium. Okay? So that's yung ating heat transfer, okay, ay radiative. Okay? So ang tawag doon ay thermal radiation. Okay? So now mag-define naman tayo ng mga parameters and processes na associated with the input or output of heat. Okay? So a process that results in the release of heat is called an exothermic process. So kapag exothermic, release of heat, so therefore negative ang Q. So a process that results in the absorption of heat naman is called an endothermic process. So kapag endothermic, nag-absorb ng heat yung system, that's positive Q. Okay? So the heat absorbed or released at constant pressure is called the enthalpy. So yung Q mo ay delta H at constant pressure. So ano man yung heat released or absorbed at constant pressure, that's delta H. Okay? So the heat absorbed or released naman at constant volume is called the internal energy of the system. So kapag yung heat mo naman ay absorbed or released at constant volume, so minamaintain mo yung volume, yung heat na yon ay yung delta U. So Q is equal to delta U at constant volume. Okay? So for ideal gases, the supply of heat can cause one of the following effects. So kapag nag-supply ka ng heat while maintaining the pressure of the gas, okay, that's an isobaric expansion. So mag-expand yung gas mo, magbabago yung volume niya, pero constant yung pressure. So Q is then N, number of moles of gas, times yung heat capacity at constant pressure, okay, times the difference between T2 and T1. So this Q is delta H. Okay? So kapag ka naman nag-input ka ng heat at constant volume, ibig sabihin yung initial and final volume mo ay pareho lang. Okay? So that's an isochoric heating. So hindi nag-expand or nag-contract yung gas mo kasi maintained yung volume. So the equation is Q is equal to number of moles times yung constant volume heat capacity or yung CV times the difference between T2 and T1. So the heat is delta U. Okay? So delta U is heat released or absorbed at constant pressure. So kapag naman ang iyong heat input ay at constant temperature, okay? So that's called an isothermal or constant temperature expansion. Okay? So isothermal meaning maintain yung temperature. So yung heat mo matatranslate siya into work kasi hindi nagbago yung temperature ng system mo. So lahat ng heat mo ay matatranslate into the expansion process. Okay? So yung delta H and delta U mo ay 0 kapag constant temperature. Kasi pansin nyo sa formula, kailangan ng difference para magkaroon sila ng value. So kapag same yung T1 at T2, pareho silang 0. Okay? Yung delta H and delta U. Okay? So here we have some final notes. So heat is a path variable. So yung Q in general, path variable siya kasi maraming ways para mag-input ng heat or mag-release ng heat ng system. Pwedeng at constant pressure or at constant volume or at constant temperature, etc. So nakadepende dun sa kung anong mga parameters yung minamaintain nyo. So in general, yung Q nyo ay path variable. So the value depends on the type of process. However, okay, at certain conditions, heat becomes a state variable. So yung Q in general, path variable siya. Pero yung delta U at saka yung delta H, they are state functions. Kasi kung makikita nyo, nakadepende lang siya dun sa differences in the temperature. Okay? So, nagiging state function yung Q kapag constant yung either yung pressure or yung volume. Okay? So kapag constant yung pressure, nagiging delta H yung Q, ibig sabihin yung Q nyo ay nagiging state function. Ganun din kapag constant volume, nagiging delta U naman siya, it's a state function as well. So enthalpy and internal energy are specific types of Q, but they are state functions. They are defined only at specific conditions of P and V. So again, okay, Q is a path function, but yung delta H and delta U nyo ay state functions. So yung delta U and delta H are manifestations of Q, pero they are state functions. Okay? So now let's proceed to the definition of work. So work is a directed form of energy. So unlike Q na dissipative, random yung spreading ng energy, yung work ay directed. Meron siyang direction. Okay? So vector quantity kasi ang work. So there are different types of work according to thermodynamics. Okay? So the first type is the pressure volume work. So pressure volume work is self-explanatory. Okay? This is an expansion or compression of gases. Pero ang criteria nito, dapat yung gases nyo hindi nagre-react or dapat inert siya para purely pressure volume work lang yung ma-account natin dun sa changes in the energy. Okay? So the formula for work or the pressure volume work is this. So work is negative P external. Ito yung pressure na in-exert from the surroundings. Okay? Tapos the difference between the volume, okay? Final volume minus initial volume. Okay? So kapag expansion work, yung work mo ay less than 0 kasi yung gas mo yung nag-exert ng work. okay, doon sa surroundings. So, the gas expands, therefore the work done is outward. So, ibig sabihin, less than zero yung work. Okay? So, nag-change yung volume. Lumaki kasi yung volume niya. Okay? So, this value is positive. So, negative P dV or P delta V is less than zero. Okay? So, yung negative sign kasi dyan, para makasunod siya sa convention. So, nilagay yung negative P delta V, yung negative doon, para makasunod siya sa convention. Kasi kapag nag-expand yung gas, lumalaki yung volume niya. So, negative P delta V, okay, should be negative. Kasi the gas is performing the work. Okay, so, nagkakaroon ng outward action. Okay, so expansion is negative W. So kapag compression naman, mas maliit yung final volume sa initial volume, so ang value nito ay negative, so negative times negative, positive yung net work done. So yung system mo naman yung nag-exert ng work sa surrounding. So compression yung action nito. Okay? So now let's discuss expansion and compression work in detail. So nakadepende rin sa number of steps, kumbaga, yung ating value ng work. Okay? So for example, you're trying to expand the gas from P1 V1 to P2 V2. So, pwede mo naman gawin na isang step lang. So, from P1, diretso ka na sa P2. So, i-expand mo siya. So, bababaan mo yung pressure from P1 to P2. Tapos, yung gas mo mag-expand na siya from V1 to V2. So, isang step lang yan. Okay? So, that's a single expansion step. So, ang mangyayari, itong point na to ay magiging P2 V1. Okay? So, ito yung magiging work done mo, the integral or the area under that graph. Okay? So, kapag ka 2 steps naman, pwede kang magkaroon ng initial expansion step right here. So, magkakaroon ka ng P1.5 tapos V1.5. Okay? So, ito yung una mong expansion step kasi this one is decrease in pressure muna tapos increase in volume. So, meron kang intermediate na state. Tapos, from P1.5 to P2 tapos yung volume mo from V1.5 to V2. So, nagkaroon ka ng P2, V2 na. So, dalawa yung steps na ginawa mo. Okay? So, dalawang PV steps to. So, mas malaki yung value ng work kapag ka 2 steps. Okay? So, kapag ka infinite number of steps naman, meron tayong tinatawag na DV. So, this is an infinitesimal volume change. So kapag infinitesimal volume change, sobrang liit nung changes sa volume every time nagkakaroon ka ng expansion steps. So kapag infinitesimal yung volume change every step, para ma-expand mo yung gas mo from P1 V1 to P2 V2, kailangan mo ng infinite steps. Okay? This is actually a hypothetical expansion process. So ang tawag dito ay reversible expansion. So kapag reversible expansion, pinakamalaki yung work required. Okay? So as you increase the number of expansion steps, nagkakaroon ka ng increase in the work required or the work done by the gas. Okay? So pinakamalaking work yung nagagawa ng gas kapag ka infinite yung steps. Pero least amount of work yung nagagawa ng gas kapag ka isa lang yung ating expansion step. Okay? So the reversible expansion work is the maximum work that a gas can perform when expanding. Okay? So now, discuss naman natin yung compression work. Ganun din ang compression work tulad na expansion work. Nakadepende rin yung amount of work sa number of steps. So for example, from P2 V2, okay, gusto mong i-compress yung gas to P1 V1. So gagawin mo, increase mo muna yung pressure and then magde-decrease yung volume ng inyong gas. So this is one step. Okay? One step compression. Kapag 2 steps naman, 2 PV steps ang gagawin mo. So, increase ka muna to P 1.5, tapos magde-decrease yung volume mo from V2 to V1.5. So, this is step 1. So, mag-increase ka ulit ng pressure to P1, magde-decrease yung volume ng gas mo to V1. So, this is 2. Okay? So, dalawa yung PV steps or dalawa yung compression steps na ginawa mo. Okay? So kapag ka naman infinite number of compression steps, so i-increase mo yung pressure by dP, tapos increase mo rin yung volume by, or magde-decrease yung volume niya by dV. So kapag infinite number of steps, that's called a reversible compression. So mapapansin nyo, as you increase the number of compression steps, pababa ng pababa yung work required to compress the gas. So pinakamalaki yung work required kapag isang step lang. Kapag ka 2 steps, okay, mas mababa yung work required. Pinakamababa yung work required kapag reversible compression. Although, you cannot do this in real life kasi this means that you have to do the compression step infinite times. Okay? So, ito yung explanation kung bakit path function yung W. Nag-iiba-iba yung value niya depende sa kung anong process yung gagawin mo, either expansion or compression, tapos gaano karaming steps or gaano karaming PV steps yung kailangan mong gawin. Okay? So, nag-iiba-iba rin yung value ng W kapag ano. So, this is why W is a path function or the work done is a path function. Okay? So the next type of work is the so-called non-pressure volume or the non-PV work. So this type of work is not the work that is through compression or expansion. Iba yung process associated with this work. Okay? So meron tayong constant pressure or constant volume na non-PV work. So for example, we have work that drives chemical reactions. So meron tayong chemical reactions. Paano kaya na-drive yung reaction na yun from the reactants to the products? So meron tayong work involved kapag ka ganon. Meron din tayong work that drives electrical or electrochemical processes. So kapag ka may transport tayo ng electrons, ano kaya yung driving force doon? Okay, so that's also a type of work that is non-PV or non-pressure volume. Okay, so processes with negative non-PV work are exergonic processes. So kapag negative yung inyong non-PV work, exergonic ang tawag doon. So yung mga processes na may exergonic na type ng non-PV work, they are usually spontaneous reactions given the conditions. Okay, or spontaneous processes given the conditions. So kapag yung process mo naman ay may positive na non-PV work, ang tawag doon ay endergonic. So yung driving force required siya para magkaroon ka ng process or para mag-push yung process forward. Okay? So these are non-spontaneous events. So spontaneous processes are processes that don't require external influence kasi yung driving force nila negative or yung nilang non-PV work negative. So yung non-spontaneous naman, yun yung mga processes na merong required na driving force. So kailangan mo ng input of influence or energy para mag-work sila. Okay? So yun yung may mga positive na non-PV work. Okay? So yung mga endergonic kumbaga. So at specific conditions, the non-PV work becomes a state variable. Kasi yung non-PV work in general, okay, depende pa rin kung ano yung constant, yung pressure ba, or yung volume, or yung temperature and pressure, or temperature and volume, etc. So may manner pa rin. Okay, nakadepende pa rin dun sa manner ng work or sa manner ng process kung paano nag-change yung value ng work. Okay? So the non-PV work at constant temperature and volume is called the Helmholtz free energy or the delta A. Okay? While the non-PV work at constant temperature and pressure is the Gibbs free energy delta G. So kapag ka negative yung delta A at constant temperature and volume, ibig sabihin, spontaneous yung process mo at that condition. Okay? Nangyayari siya ng kusa. Okay? So exergonic siya at constant temperature and volume. Kapag ka naman endergonic at constant temperature and volume, positive si delta A. Ganon din sa delta G. Kapag ka at constant pressure and volume, or at constant temperature and pressure, yung delta G ay negative, ibig sabihin, spontaneous siya. Okay? Exergonic. So at constant temperature and pressure naman, kapag ka endergonic siya, ibig sabihin positive yung delta G, non-spontaneous naman yung ating process. Okay? So yun yung mga functions na nangyayari or yung mga state functions na nag-a-arise kapag ka meron na tayong specific conditions of temperature, pressure, and volume dun sa ating process. Okay? So again, yung non-PV work in general, it's a path function. Pero yung delta A and delta G, okay, yung Helmholtz at Gibbs free energy, sila ay mga state functions kasi sila ay nasa specific conditions lang ng inyong process. Okay? Nag-a-arise lang sila at specific conditions of temperature, pressure, and volume. Okay? So in summary, we have Q and W. So yung Q natin, that's heat or the dissipative form of energy. Yung work natin ay directed form of energy. Okay? So path function sila kapag hindi specified yung conditions ng temperature, pressure, or volume. So kapag heat is released by the system, that's exothermic, negative Q. Kapag heat is absorbed by the system naman, that's endothermic or positive Q. Okay? So sa work naman, we have two types, PV work and non-PV work. So kapag PV work is negative, expansion. Kapag PV work is positive, that's compression. Kapag yung non-PV work nyo ay negative, that's an exergonic process. Kapag naman yung work nyo or yung non-PV work nyo ay positive, that's an endergonic process. Okay? So at conditions of, or specific conditions of temperature, pressure, or volume, nagkakaroon tayo ng mga state functions from these path functions. So kapag heat is absorbed or released at constant pressure, delta H. Kapag heat is absorbed or released at constant volume, delta U. So kapag constant na yung temperature, okay, so magkakaroon tayo ng heat released or absorbed at constant temperature, latent heats na ang tawag doon. So latent heats are heats at constant T. So, hindi necessarily na kapag nag-generate ka ng heat or nag-absorb ka ng heat, magpapalit na agad yung temperature mo. Depende pa rin yun sa process. Pwede ka mag-absorb or mag-release ng heat without changing the temperature. So, yung energy associated with those things or with those processes, ang tawag doon ay latent heats. So, delta H kapag constant temperature and pressure yung process mo, delta U kapag constant temperature and volume yung process. So, latent heats na ang tawag sa kanila. Okay? Pero delta H and delta U pa rin sila kasi pressure kapag delta H, volume kapag delta U. Okay? Constant ang P pag delta H, constant ang V kapag delta U. Okay? So, sa work naman, if your non-PV work is performed at constant temperature and volume, okay, that's delta A. Kapag naman the process is at constant temperature and pressure, the work or the non-PV work is delta G. Okay? So that's a summary of the definitions of heat and work in terms of the various conditions. Okay? Kapag nag-apply na tayo ng iba't ibang conditions, nagkakaroon na sila ng iba't ibang definitions. Okay? So this is my discussion on the basic elements of thermodynamics. So sa susunod na discussion, I'll discuss calorimetry and some calculations. Okay? So see you next video.